Alright, this is section 4.1, the antiderivatives and the indefinite integration. Alright. So, the activity, suppose we want to find f of x whose derivative is this, 3x squared. What would it be? Well, turns out there's a bunch of them. Any of the following will be the functions that have derivatives that equal the above function. Right? So if I took the derivative of x cubed plus 1, that'll be 3x squared, and the plus 1 just goes away. So that's 3x squared. If I took the derivative of x cubed minus 7, it'll be 3x squared. So this plus c idea here, so it represents a family of answers. Okay, this represents a family of answers. So you're going to see this plus c frequently. So that is the constant, it's called the constant of integration. Right? This plus c is called the constant of integration because it pops up. Because whenever you take the integral of something, when you take the derivative backwards, there is this constant that just pops up, right? So this plus 1, it could have a plus 1, it could be a minus 7, it could be minus pi. There's some value that goes away when you take the derivative of something, right? Now that doesn't mean it has to exist. C could be 0, right? Then it would be just x cubed. But the idea here is there's a family of answers to that question. What is this a derivative of? What is 3x squared a derivative of? It's x cubed plus any constant. All right, so that's a family of answers. All right, and instead of writing what function would have a derivative of x, and we write it this way. So the integral of f of x equals capital F of x plus c. All right. So here's some basic integration rules. So if we have the integral of 0, it's a constant, just a constant. If we have an integral of a constant, it's kx plus the constant. And if we have the integral of k times a function, that k, which is a constant, not a variable, can pop out of the integral and be k times the integral of the function. Okay, so none of these are earth-breakingly important, right, or surprising, right? So 3, 4, and 5 are not surprising, or should not be surprising. 1 and 2 are basic rules, and number 6 is a basic rule. All right. So number 4, it's the integral of two functions is the same as the integral of the functions separately, right? Add the two functions separately, or do the integral separately. If you have a integral of the difference of two functions, just do the integral separately. Okay, and sometimes we do that, and sometimes we don't. All right, but anyway, so this is the first new rule. So this is the power rule for integration. The power rule for integration. So remember when you take the power rule for derivatives, you subtract 1 from the exponent and multiply. Well, you multiply by the old exponent. Here, what we're going to do is you're going to go backwards. Instead of subtracting 1 from the exponent, we're going to add 1 to the exponent, and we're going to divide by the new exponent. All right. So and then plus a constant. So that's what that is. So number 1, find each of the following integrals. So the exponent is currently 1. So when we integrate that, that's going to be 3x squared, right? You add 1 to the exponent and divide by the new exponent, and you add a constant. So that's the answer to A. B, now a lot of people get confused with this kind of problem. So we just rewrite that as x to the negative 3 dx. And then now use the power rule now. So that's going to be x to the negative 2 divided by negative 2 plus c. And let's not leave it like that. What we're going to do is clean that up, make it negative 1 over 2x squared plus c. Okay? All right. Let's go into c. So this is, rewrite this again. Rewrite as x to the half dx. So we add 1 to the 1/2. So that'll be x to the 3/2 divided by 3/2 plus c, and go ahead and clean that up. That's going to be 2/3 x to the 3/2 plus c. And there's no need to rewrite that as a square root. Okay? All right. So we haven't learned anything to do a product. There is a product rule for taking the antiderivative, but it's not called a product rule, and it's actually a very advanced technique. So that means you can't take the integral of this. There's no product rule like this for integration. So what I'm going to do is just go ahead and multiply it out. Right? Remember, that's x to the 1/3. Right? That cube root is x to the 1/3. So if I multiply this out, that becomes x to the 4/3 minus 4x to the 1/3 dx. And now we're going to Add 1 to the exponent, so it'll be 7/3, and divide by the exponent. Remember, so if I divide by 7/3, that's the same as 3/7 minus, oh, this is going to be a mess. So I'm going to do this in stages. So you add 1 to the exponent, so that's 4/3. Divide by the new exponent, 4/3. I skipped a step here in hopes of having this, because I knew I was going to run out of space. So continuing that, so it's 3/7 x to the 7/3. So I'm going to flip this, so it's going to be 3/4. So the 4 gets canceled, so it's 3x to the 4/3 plus c. That's that one. E, continuing with the same idea, right? So that's x to the 1/2. So I'm going to rewrite it as x over x to the 1/2 plus 1 over x to the 1/2. So what I've done, whenever it's a monomial in a fraction, you can divide each term in the numerator by that monomial. So when I do that, I get x to the 1/2 plus x to the negative 1/2. Okay. And you add 1 to the exponent, divide by the new exponent. So the new exponent is 3/2. If you divide by 3/2, you get 2/3. Here, you add 1 to the exponent, you get a positive 1/2. Then you divide by 1/2, the same as multiplying by 2, plus the constant. Okay. Oh, here, t squared plus 1 squared. I'm going to run out of space, so let's just do it down here. Alright, so integral. So there is no chain rule. Actually, I'm sorry, there is a chain rule, but even chain rule doesn't fit for this. Okay, so what we're going to do is expand it. So that's going to be t to the 4th plus 2t squared plus 1. So if I square t squared plus 1, that's what I get. And go ahead and do the power rule. So that's 1/5 t to the 5th plus 2/3 t to the 3rd plus t plus the constant. So I add 1 to the exponent, divide by the exponent. That's where that 1/5 comes from. Add 1 to the exponent, so that'll be 2 becomes 3, and divide by the new exponent. That's where the 2/3 comes from. The integral of 1 is t. You haven't seen that recently, so that's like this one. The integral of 1 dx is 1x plus c. Right, that's what that was. So it's t plus c. And that's all the examples on page 119.